All right, so we're going to go over some basic properties of exponents, but the purpose of this video is to show you that if you don't remember any of these properties, you can always sort of figure them out for yourself. So start with the basics. If we have two powers of the same base multiplied by each other, what does that mean, or what do we do? So let's make ourselves an example. If I have, say, x squared times x to the fourth, I can always expand that. X squared means x times x. X to the fourth would be x times x times x times x. And if those are multiplied together, then really I just have 6 x's multiplied together, or x to the 6. So in other words, if I look at my original example, really if I have a power times another power, I really could have just done 2 plus 4 equals 6. So if I have x to the m times x to the n, I can really just add up those exponents, x to the m plus n, to get my new power. Of course, the base being the same. All right, so then similarly, if I'm dividing two powers, so say I have x to the m divided by x to the n, well, let's do an example, x to the fifth divided by x to the third. If I, again, expand that, that would be x times x times x times x times x over x times x times x. But if you're dividing a number by itself, assuming, of course, it's not 0, then x divided by x would equal 1. X divided by x is 1, x divided by x is 1. So what I'm left with is just x times x, which is x squared, and actually it would be over 1 technically, but x squared over 1 is really just x squared. So notice, because I was canceling, really what I could have done is just subtract what's going to cancel out. So 5 minus 3 would give me 2. So if I have x to the m divided by x to the n, I can just subtract those exponents to get my new exponent. All right, one more example. So say I have a power raised to a power. So think about like x squared raised to the third. What does that mean? Well, if anything's raised to the third, that means everything inside this parentheses is being multiplied 3 times. So that's x squared times another x squared times another x squared. And actually, at this point, I can use my property up here when I'm multiplying two powers, right? And, you could write it all out. But I know that I can just add up those exponents. So 2 plus 2 is 4 plus 2 is 6. So that would give me x to the 6th. So looking back at the beginning, when I had a power raised to another power, I was really just doing 2 3 times, or 2 times 3 to get 6. So x to the m raised to the n is x to the m times n. So a power raised to a power, I'm going to multiply. A silly little acronym, if you want, is MAD SPAM, which is if you're multiplying powers, you add the exponents. If you're dividing powers, you subtract. And if you have a power of a power, you multiply. All right, so those are the basic 3. But then we also come across a couple other things. So for example, what if I have a negative exponent? So we know, for example, x squared means x multiplied 2 times, but can you multiply something a negative number of times? Seems a little odd. So let's look at it. So take a look at this example we did up here, and let's try flipping it. Say I had x to the third divided by x to the fifth. Now we know from this property that we can just subtract those exponents. So 3 minus 5 gives me negative 2. But what does that really mean about my x's, whatever they may be? Well, let's go back to our expansion. X to the third over x to the fifth was x times x times x over x times x times x times x times x. And if I start canceling again, that comes 1, that's 1, that's 1. I still end up with x times x, which is x squared, but notice it's on the bottom of this fraction, so these all, of course, divided out to be 1, so that's really 1 over x squared. So when I had x to the negative 2, it was x squared, it was just on the denominator of the fraction. So this and this are the same, so for example, if I had x to the negative fifth, that would be the same as 1 over x to the fifth. Or in general, x to the negative n would be 1 over x to the nth. So I can make an exponent positive by just putting it on the bottom of a fraction.